All right, so now we're going to go over the case of a completely inelastic collision where the objects stick together. So in that case, we still have the same initial conditions as previously, where we are going to be pushing one cart into another cart that's stationary. Um, in the lab, in this case, what's going to happen is we're going to have attractive magnets and Velcro that helps the cards stick together. So they will stick together once they run into each other. Now, for this, we only have conservation of momentum, but what we have is that afterwards, if we look at the situation afterwards, we have basically two objects stuck together with mass m1 plus m2, and we're just going to call it v prime because they're both moving at the same velocity. So then, using conservation of momentum, we have m1 v1 equals m1 plus m2 v prime. And so from this, we can figure out what the final velocity will be just based off of the initial velocity of the first object and the masses. One thing that we are going to look at is the amount of kinetic energy lost in this situation. So we know that it won't be equal, but what we'll do is just say that the initial is equal to 1/2 m1v squared, and the final is equal to 1/2 m1 plus m2 v prime squared. Now we can plug in the value for v prime. One squared v 1 squared over and we can cancel this squared with the term that's in the numerator. Once we simplify this and factor out the 1/2 m1 v squared, v1 squared, what we end up with is m1 times m1 plus m2, divided by m1 plus m2 times the initial kinetic energy. So now we want to talk about how much energy is lost, and the easiest way to do that is talk about the fraction of the kinetic energy that's lost. So we want to know how much is lost over the initial total, which is initial minus final over initial, or 1 minus final. That's a mess. One minus final over initial. So if we divide this by the initial, we get 1 minus m1 over m1 plus m2, or m2 over m1 plus m2. And so just thinking about this by, kind of looking at the limit of when m2 gets very large or very small. If a very light object hits a very heavy object, this is going to get close to 1, so almost all of the energy is going to be lost. Whereas if a very heavy object hits a very light object, very little of the kinetic energy will be lost. And that makes sense because, if you take, your car hitting a bug, it's not going to change anything about what speed your car is going very much or how much energy it has. You're just going to squash the bug and keep going at basically the same speed and energy.